Are we alone in the universe? If there are indeed other civilizations out there, why haven't they contacted us? Why haven't we heard from our cosmic neighbors? It's hard to believe that we're the only sentient beings in this grand cosmic theater. Our universe is a vast expanse. There are billions of stars in our galaxy alone, and the universe contains billions of galaxies. With the sheer number of celestial bodies out there, it's almost a statistical certainty that life, in some form or another, exists beyond our blue planet. Yet this brings us to a puzzling paradox, the Fermi Paradox. If the universe is teeming with life, as our calculations suggest, why is it so quiet? Where is everyone? Welcome to GSD, Brainers, the place where curiosity meets discovery. This brings us to a mind-boggling conundrum known as the Fermi Paradox. If you've ever gazed up at the night sky and pondered the existence of life beyond our planet, then you've unknowingly grappled with the Fermi Paradox. Named after the physicist Enrico Fermi, this paradox presents a contradiction that has puzzled scientists and philosophers for decades. The Fermi Paradox is essentially the disparity between the high probability of extraterrestrial life and the startling lack of evidence or contact to support this. It's like throwing a grand party, sending out countless invites, but no one turns up. You're left standing alone in a room full of balloons and uneaten cake, wondering where everyone is. Enrico Fermi, the man behind the paradox, was an Italian physicist known for his work on the development of the first nuclear reactor. The paradox itself, however, was born out of a casual lunchtime conversation. Fermi, while discussing the possibility of advanced civilizations in our galaxy, suddenly blurted out, "Where is everybody?" This simple yet profound question encapsulates the essence of the paradox. Here's the crux of the matter. Given the sheer scale of the universe, with its billions of stars and potentially habitable planets, it seems highly probable that intelligent life must exist somewhere out there. Yet despite decades of searching, we've found no signs, no signals, no intergalactic postcards, nothing. This glaring contradiction between the high estimates of probability and the lack of evidence is what forms the Fermi Paradox. It's like having a treasure map, knowing the treasure is out there but not finding a single gold coin. It's perplexing, frustrating, and utterly fascinating. The Fermi Paradox forces us to question our understanding of life, existence, and our place in the cosmos. It challenges us to confront the possibility that we might be alone in the universe, or perhaps that we're simply not listening in the right way. Now let's delve deeper into the complexities of this paradox. The Drake equation is a crucial piece of the Fermi Paradox puzzle. This mathematical formula, proposed by astrophysicist Frank Drake in 1961, is our best attempt yet at estimating the number of advanced civilizations in our galaxy, the Milky Way. The equation itself is a series of variables multiplied together. Each variable represents a key factor in the development of advanced civilizations. The first variable, for example, is the rate of star formation in our galaxy. Stars are the cosmic ovens where planets are baked, so the more stars, the more potential homes for life. Next up, we have the fraction of those stars that have planetary systems. Then the average number of planets that could potentially support life per star with planets. These variables are all about real estate, the number of places where life could get a foothold. Then we have the fraction of planets that could support life where life actually develops, followed by the fraction of that life that develops into intelligent beings. It's not enough for life to start. It needs to evolve, to learn, to become intelligent. The penultimate variable is the fraction of civilizations that develop a technology that releases detectable signs of their existence into space. This is where we get into the territory of science fiction, but it's crucial. If a civilization never learns to broadcast its existence, we'd never know they were there. Finally, we have the length of time such civilizations release detectable signals into space. This is a sobering variable. Civilizations might not last long, either self-destructing or falling victim to cosmic cataclysms. Each variable in the Drake equation is a gate, a hurdle that life must clear on its journey to becoming a civilization we could potentially communicate with. When we plug in our best estimates, the result is a surprisingly large number of potential civilizations. 100,000 civilizations in our galaxy alone. 100,000 civilizations mean they should be everywhere, transmit signals to every direction. Yet we've heard nothing. No signals, no hello, no evidence of anyone out there. That's the Fermi Paradox, the cosmic conundrum. Considering the Drake equation, the silence from the cosmos is indeed puzzling. Despite the paradox's complexities, scientists have proposed several solutions. So let's dive into some of the most popular theories out there that attempt to unravel this cosmic conundrum. First off, we have the zoo hypothesis. Now, this isn't as wild as it sounds. It's the idea that we're like animals in a zoo. An advanced extraterrestrial life is watching us, but they've decided not to interfere. Think of it like an unspoken prime directive from Star Trek, where advanced civilizations agree not to mess with the natural development of less advanced ones. It's a plausible theory, but it does make you feel a bit like gazelles in National Geographic, doesn't it? Next up is the rare Earth hypothesis. This theory suggests that the conditions required for intelligent life are so incredibly specific and complex that they might be extremely rare, even in the vast cosmos. It's not just about having a planet in the Goldilocks zone where liquid water can exist. You also need a whole bunch of other factors to line up perfectly, from the right kind of star, to a stable planetary orbit, to the presence of certain chemical elements. So maybe we're not alone, but the neighbors are just very, very far away. Lastly, there's the possibility that civilizations are actively avoiding contact. This is often referred to as the dark forest solution, named after a concept from a science fiction novel. The idea is that civilizations might be keeping quiet to avoid attracting the attention of more advanced, potentially hostile civilizations. It's a bit like being in a dark forest, where it's safer to stay quiet than to shout out and reveal your location. Even darker scenario, a super predator civilization far more advanced than all the rest could silence them one by one to avoid any competition, wiping them all out. Maybe we should have thought twice before sending that greeting with directions to Earth in the 1960s. These solutions, though fascinating, are yet to provide a definitive answer to the Fermi Paradox. But they do give us a lot to ponder on, don't they? In the end, the search for extraterrestrial life continues, and who knows what we'll discover as we keep peering into the vast expanse of the cosmos. We still need to talk about the scariest part of the Fermi Paradox. But before we continue, we want to thank you all for your support. We couldn't create these videos without you. We appreciate every like, comment, and subscribe. Picture a colossal wall, a barrier of sorts, standing in the way of life itself, threatening the existence of a level 3 civilization. The concept of the Great Filter is a theoretical idea that suggests there is a barrier or obstacle in the development of life that makes the existence of detectable extraterrestrial life rare. The Great Filter can be interpreted in different ways. It could be an internal event or process that poses a challenge to the development of intelligent life, such as the emergence of life itself, or the evolution of complex organisms. Perhaps civilizations tend to self-destruct before reaching a level of technological advancement that allows for interstellar communication. Or maybe it's a natural disaster on a cosmic scale. Here's where it gets even more intriguing. If the Great Filter exists, it raises a crucial question. Have we as humans already faced this Great Filter, or is it still lurking in our future? If it's in our past, we can breathe a sigh of relief. It means we've already faced the worst and survived. We've dodged the cosmic bullet, so to speak. However, if it's yet to come, that's a different story. It means the worst is still ahead. It means that our journey towards becoming a Type 3 civilization could be cut short. It means that we, like many other life forms that have come before us, might hit this wall and never get past it. So we're left with a chilling question: are we past the Great Filter, or our extinction in our future yet to come? This paradox isn't just a scientific query, it has profound implications. It's not just about wondering whether we have cosmic neighbors. The Fermi Paradox forces us to ponder our place in the universe. Are we alone, a unique spark in the vast cosmic dark? Or are we simply an ordinary phenomenon? yet to connect with others in the galactic neighborhood. The paradox also makes us contemplate the future of humanity. If advanced civilizations have indeed annihilated themselves, as some solutions suggest, it serves as a sobering warning for our own species. We need to tread carefully as we advance, lest we trigger our own great filter event. On the flip side, if the galaxy is teeming with life that has merely chosen to remain silent, it sparks a sense of wonder and curiosity. It motivates us to keep exploring, keep searching, keep reaching for the stars. The Fermi Paradox, a silent question echoing through the cosmos, remains unanswered. But it continues to inspire us, to challenge us, and to shape our understanding of the universe. And maybe it's not that they are not there. Maybe we just don't understand their communication. Maybe we already received direct message from our friendly alien neighbors and we just couldn't understand. We might have the answer. And the answer is, well, it's in this video right here, so don't miss out. And enjoy the rest of your video.